Hey everybody, welcome to another exciting episode of the Philosophy Garage with Professor Parsons. It's cold, so once again I have a nice fire going in the wood stove, and today I'm going to be talking about a problem in philosophy of science and just generally when it comes to epistemology, known as the Grue Paradox, which was formulated by philosopher Nelson Goodman in his book Fact, Fiction, and Forecast. And the Grue Paradox came to be known as the new riddle of induction. So it's differentiated with David Hume's problem of induction or problems of induction. All right. So just to recap some of the relevant material with David Hume. So David Hume when it comes to induction is largely concerned with the question of how what's known as enumerative induction can at all be justified. So Hume is concerned with the question of how can it be shown that inductive methods are reliable methods just across the board. And what we mean by enumerative induction, again, is this process of making past observations and coming to some understanding about how our past observations give us grounds to make judgments about future observations. So to what extent does repeated observed behaviors or patterns in the world give us reason to think that those patterns or behaviors are confirmed, or that our judgments about the likelihood of those patterns and behavior continuing at a future time are confirmed. Okay, now Nelson Goodman thinks that David Hume just largely gets the issue wrong here. The riddle of induction or the associated problems with induction are not that we can't show that certain inductive methods are in fact reliable. So the problem is not that we don't have what he would call a program or system of confirmation. That's not the problem. We may have, and Goodman thinks that we actually can give a reasonable account of confirmation. Now, the problem with inductive methods is this. If a given method of confirmation is justified or is in fact reliable, that means that a given body of evidence can be used to equally support two rival hypotheses, claims, or theories. So in science, what we want is we want to have certain claims and hypotheses confirmed by the evidence and the data that we have available. What the Grue Paradox aims to show with this new riddle of induction is that, okay, well, if the data that you have or the evidence that you have confirms one hypothesis or one theory, then it equally confirms another hypothesis or another theory or claim, and that is a rival hypothesis or theory. So when it comes to rival claims or hypotheses, the idea is that they are mutually exclusive. They need not be mutually exhaustive, but they are at least mutually exclusive, meaning that they can't both be true. Okay, now, so to get into the actual paradox, we'll just be using some reasoning that we typically use on a daily basis. Okay, so for example, it is true that all emeralds that we have observed have been green. That is true. So all observed emeralds are green. And most of us would say, well, the fact that every emerald that we've ever observed is green, that actually confirms the claim that all emeralds are green. So we have inductive confirmation for the claim that all emeralds are green. So we can reasonably expect that the next emerald that we discover that has not been observed by anybody else before is green. That is generally how enumerative induction works. Okay, now, so Nelson Goodman then gives us this definition of Grue. So Grue, something is Grue, by definition, if it is green and first observed prior to 2021, or you can just pick any arbitrary future time. It just needs to be a time that's later than this exact moment. All right, so we'll just go with 2021 for the sake of simplicity. So an object is Grue if it is green and first observed prior to 2021, or it is blue and it's first observed after 2021. So an object is Grue if it is green and it's first observed prior to 2021, or it's blue and it's first observed after 2021. Okay, so what does this have to do with emeralds? Well, think about it. So it is true, like we said, that all emeralds that have been observed are green, right? It is also true that all emeralds that have been observed prior to 2021. I mean, obviously it's 2020 right now, so we can't observe future emeralds. That doesn't make any sense. Okay, so since it is true that all emeralds that have been observed are green, and it's also true that all emeralds that have been observed prior to 2021, well, given the definition of Grue, green, if first observed prior to 2021, green and first observed prior to 2021. Well, all emeralds that we've actually observed actually fit the definition of Grue, given the fact that they are all green and they've all been observed prior to 2021. Well, that means that all emeralds are Grue, right? Now, the idea here is that if we have inductive support for the claim that all emeralds are green on the basis of the data, we have equal support for the claim that all emeralds are Grue on the basis of the evidence and data that we currently have, okay? Now, and it's here that there's a common misconception about what Nelson Goodman is saying in the Grue Paradox. So Goodman is not saying that emeralds change color. So he's not saying that emeralds have this magical quality that they move from being green to being blue. So all the emeralds that we've observed prior to 2021 are green, and they're going to stay green after 2021, right? So what Goodman is getting at here is that we're moving from a claim about what we have observed to a claim about things that we have not observed. So he's not saying that if you hold a green emerald in your hand, after 2021, it's going to be blue. No, what he's saying is after 2021, all the other emeralds that are going to be observed after 2021 are going to be blue. So after 2021, we can reasonably expect that the next emerald we're going to discover is not going to be green. It's actually going to be blue. But since currently, given our current body of evidence, our current body of data, since all of our currently observed emeralds satisfy both of the conditions needed currently for emeralds to be Grue, it does seem that we have equal support for these two rival hypotheses, or these two rival claims. Now, but why exactly are the claims that all emeralds are green and the claims that all emeralds are Grue, why exactly are these rival claims? Well, here's why. So all emeralds are green implies that no emeralds are blue. So I'm not going to go back and edit emeralds there. Just add an S to the second emerald. Okay. Now, so what that means is that all emeralds, when we're talking about all emeralds, we're not only talking about the ones we've observed, we're also talking about the ones that we haven't observed. So all emeralds are green, whether they're observed or unobserved. This implies that no emeralds are blue, right? So it can't be the case that all emeralds are green and some emeralds are blue, all right? Now, but all emeralds are Grue implies that some emeralds are green and some emeralds are blue. So all emeralds are Grue implies that the emeralds observed prior to 2021 are going to be green, and the emeralds that are observed after 2021 are going to be blue. So once again, we're moving from a claim about what we have observed to a claim about what we have not observed. All right. Now, so that is why we have two rival hypotheses here. It can't be the case both that all emeralds are green and all emeralds are Grue. Those are rival claims. They can't both be true. They could both be false, but they can't both be true. Okay. Now, so you see the problem here. It may seem absurd to say that all emeralds are Grue based on our current body of data, but that is exactly what our data tells us to expect on the basis of the definition of the word Grue. Okay, now, so once again, what this points out is that from the empirical data alone, from the empirical evidence alone, we cannot decide between rival hypotheses, rival claims, or rival theories. The empirical data, the empirical evidence on its own does not confirm one hypothesis over any other rival hypotheses. So this is a big problem for inductive methods or methods of confirmation or programs of confirmation, because what this means is that for any body of data which seems to confirm one hypothesis, there's an infinite number of rival hypotheses that empirical data or empirical evidence equally supports. So on the basis of the empirical data or the empirical evidence alone, we can't adjudicate which of our hypotheses, claims, or theories are actually confirmed on the basis of the data. Or at least, but the qualification here is that we can't understand empirical evidence or empirical data or confirmation purely in terms of rational or evidential terminology. So what Goodman is going to say eventually is that scientific enterprises, to the extent that they rely upon induction and confirmation, the very notion of induction and confirmation is not just established on the basis of reasoning about what confirmation is. Our very methods of confirmation and induction and science, for that matter, are largely dependent upon the language that we use and the terminology that we actually define and establish, mostly through stipulation, in our scientific methods. Okay, now, but I'll come back to that momentarily. But before we get to that, I just want to address some potential responses to the Grue paradox. Okay, so one response is this. One response is that green is a much simpler predicate than Grue is. So to understand whether or not an object is green, it seems you just need to have a certain kind of perception of it. And it's going to be a ceteris paribus condition that your powers of observation, particularly when it comes to vision and things like that, are working correctly. That's going to be a ceteris paribus condition. But when we're talking about whether or not something is green, kind of in Humean terminology, just names. Green is a name for a certain kind of perception. So green is the sensation you have when you look at this object. Blue is the sensation you have when you look at this kind of object. Now, but when it comes to Grue is not a simple predicate. Grue is what we would call a disjunctive predicate, since it's green or blue on the basis of what time it is right now. Okay, now it certainly is true that given just our nuances of language, Grue happens to be a more complex predicate than green is. But that's not an interesting fact about sort of the nature of our perceptions per se, and it's certainly not an interesting fact just about the objective nature of the world. Again, this is just dependent upon linguistic convention here. So we choose to use the word green in a certain kind of way. That's just been the history of how words like blue and green have been used. But just because they have been used that way, that doesn't necessarily tell us anything interesting about facts in the world objectively determining, per se, the meaning of our words. Now, and here's why. So we could use Grue and another kind of word, bleen, as sort of primitive predicates and define green and blue potentially in terms of Grue and bleen. All right, so here's one way of doing that. So we could say this. We could say that an object is green if it is Grue and first observed prior to 2021, or bleen and first observed after 2021. So the fact that, just as history indicates, we define Grue in terms of green and a time index, well, that's not necessarily a problem for the term Grue, because we could define green that way. So the fact that we actually define Grue in terms of green doesn't mean that green just objectively speaking, is a primitive concept, and Grue is not. Grue is a more complex concept. Why? Because we could just stipulate, okay, well, from now on, we're going to define green in terms of Grue and Bleen, rather than defining Grue or Bleen in terms of green and blue. So we can define things a completely different way. All right. Now, the other issue that might come up, and this is related to the first one, is that Grue is a time-indexed predicate, while green is not a time-indexed predicate, right? So when we're talking about whether or not something is Grue, whether it's Grue does depend upon what time it is, but it seems that whether or not something is green does not at all depend upon what time it is, okay? Now, and Goodman just says here, once again, all right, the fact that we don't define green in a way that is time indexed, where whether or not something is green or blue for that matter depends upon the time that it is first observed. Okay, so the fact that we don't define green that way, that doesn't mean that we couldn't define green that way. So a lot of the terminology that we use, whether it be predicates or not, might be perfectly fine to define or explain in a kind of time-indexed way. Okay, so for example, any time, and these aren't predicates, mind you, but they're nevertheless descriptive phrases. So largely anytime we use a descriptive phrase of certain kind, they are implicitly time indexed. Okay, so here's an example. If in 2020 you asked me who my favorite band is, John, who is your favorite band? I'm going to give you a different answer in 2020 than I would give you in 2004, right? Why? Because my musical tastes have changed in the last 16 years. So here we have one descriptive phrase, my favorite band, or even if you want to make it specific, John's favorite band. So John's favorite band is one descriptive phrase. Well, at one time, John's favorite band is going to refer to one class of entities, and in 2004, John's favorite band is going to refer to a completely different class of entities, right? So it's implicitly time indexed here. So the descriptive phrase John's favorite band is not explicitly, we're not saying X, the class of entity C is John's favorite band just in case, it's 2004, right? It's not explicitly named that way, but implicitly speaking, it is time indexed. So my favorite band in 2020 refers to one class of entities or one entity. And then in 2004, John's favorite band refers to a completely different class of entities. Why? Because our musical tastes change over time, right? And I'm not going to tell you who my favorite band is right now or who it was in 2004. If you want to know who my favorite band is currently, you can just email me. Now, there's no secret about who my favorite college football team is, and that's been the case from, 1986 onwards, just because I was born in 1984, but I was too young to watch football. But right, so it's been Michigan football. So John's favorite college football team, that's been steady throughout time, but obviously my tastes in music have changed drastically. Okay, all right, now, one other option that I didn't put a slide on, so I'll just talk about it, is that, is that green is what we would call a natural property where Grue is not. So I don't want to get into the entanglements here, but the issue here is on what exactly it means for something to be a natural property versus a non-natural property. So one way is to characterize it in terms of, well, something is a natural property if things would have that property independently of human observation or human convention, and then a non-natural property would in some sense depend upon convention. But if we think about just how concepts and language work, clearly if there were no human conventions, there wouldn't really be any concepts, to the extent that concepts are largely framed in a given linguistic or conventional context here, right? So even the concepts that we use do depend largely on convention, including the distinction between the natural and the non-natural. So even if there's some distinction that might be able to be made here, that's one option for addressing this, but yeah, just for the sake of time, we're not going to get into it. All right. Okay. Now, and as I already mentioned, the conclusion that Nelson Goodman comes about this is that when it comes to inductive methods or methods of confirmation or a program of confirmation, he comes to the conclusion that our reasoning about evidence and data and confirmation cannot be separated from our language. Okay, now, so as long as we keep that in mind, we can use our methods. But the fact that certain kinds of methods of induction or certain kinds of methods of confirmation are currently in use and currently are relied upon in the sciences, in one way is that in some sense that's a historical accident, and in many ways it's completely dependent upon how we have come to define things linguistically and conceptually. Okay, now as far as other ways of dealing with this problem, other philosophers, particularly Karl Popper, are going to go along the route of, okay, we'll just completely get rid of induction from the sciences completely. So when we talked about hypothetico-deductivism and scientific theories and the deductive nomological model of scientific explanation, the verificationism of the logical positivists, these were all attempts to do away with certain problems of induction, largely Hume's problem of induction. Well, Nelson Goodman's problem of induction or riddle of induction is a completely different animal here. Okay, now, but when it comes to falsification, and this is what Quine and others are getting into, if there's a problem with understanding whether or not a hypothesis can be strictly confirmed on the basis of evidence, there's also a problem with talking about whether or not a hypothesis can be strictly falsified as well. So this is what the Duhem-Quine thesis is getting into, which we've already discussed. So if we can't strictly confirm hypotheses or claims or theories on the basis of empirical data, given the fact that all of our hypotheses themselves are going to be framed with background knowledge and assumptions, and then certain auxiliary hypotheses as well. Well, if we think we falsified a given hypothesis, how are we supposed to be able to tell whether or not it's that hypothesis we're testing or claim we're testing that is directly falsified, or whether or not it's one or more of the auxiliary or background claims or hypotheses that are falsified on the basis of the data? So it's kind of the same problem, but it's just directed in a different way. Okay, well, that will suffice for now with respect to the Grue Paradox. Hope you've enjoyed this presentation, and as always, if you have any questions, please feel free to send me an email.